All right. So in addition to all those kinds of features, let's talk about particular models that might be interesting. So this is something that I think people like to hear a lot about on this on on the show or in general is kind of latest models, latest capabilities. And so Dell recently announced a partnership with IBM around their Granite models. So Granite, like the stone. And so can one of you give me the big picture around what that partnership is all about?
Absolutely. We're pretty excited about that partnership with IBM, which we recently announced at IBM Tech Exchange. And what I'm most excited about is through that collaboration, we're actually bringing uh, really best of breed models into the AI factory that then customers can use to build, deploy, and scale rapidly across not only Dell's entire hardware ecosystem, not only from the infrastructure, right, servers to edge devices to PCs. What I really like about these models, and we're talking specifically about IBM's Granite 4.0 family of models, is that they're covered under the standard Apache 2.0 license. They are a hybrid architecture model combining state space models with transformers, and that really changes the game in terms of long context performance and memory efficiency, right? And these are enterprise grade. And why do I say that? Because yes, one, they're open source under the Apache 2.0 standard license. They're trusted. They can be trusted. Open weights, open training data for full customizability and deployment flexibility. And to top it off, they're performant, right? They're near the top of the leaderboard of the standard Helm IF eval for open weights. And actually, bookended by 100 billion parameter plus models on both sides, right? So these models really punch well above their weight. And in my opinion, they're ideal starting point for fine tuning and customizability for enterprise deployments. So Tyler, why don't you share some more about the models themselves?
Yeah, let's talk about that was a really helpful overview, and it's great to hear that it is doing so well on the Helm. I'll have a link to Helm in the show notes for people who want to understand more about that. And so this is specifically at this time, this is the fourth version of this model family. So it's the Granite 4.0 model family. And I understand
Fourth major version.
fourth major version, right? Yes, thank you for yeah. It's good we have software people on this call to get me right on my model versionings. And so within the Granite 4 model family, there is coincidentally four different variants. And so maybe you can fill us in on the details of those four variants and why you might choose one of these models for a particular use case, Tyler.
Yeah, yeah, and there's a reason I interjected there, and it was that what IBM's been doing with Granite is really exciting for enterprises. They're delivering some pretty consistent results, and I'll start with the bottom of the family and highlight that. Right, so Granite, the 3 series had a 3.0, a 3.1, a 3.2, a 3.3 version, all improving on the same model. The first model in the Granite 4 family extends and improves on that again, right? So that's the same familiar pure transformers model architecture with new knowledge and improved performance, right? So it's a great 3 billion parameter dense transformer model. Then from there, right, they get even more interesting, right? So the Granite 4 model family has the other 3 all have a H tag. So they are Granite 4H models. That H there stands for hybrid. And specifically, it's a hybrid state space model. So what the IBM team has done is they've blended state space models, which I think we'll talk about here in a minute. So I'm going to leave that definition hanging. And transformers to get great long context scaling specifically, right? One of the big things with attention mechanisms built into transformer models, one of the big limitations is memory scaling. There's a quadratic scaling law. That means if you double the input context, you are quadrupling the memory required to run, for example, your KV cache in most scenarios. What a state space model, one of the important properties it has is you get linear scaling. So with the Granite 4H family of models, you have sub-quadratic scaling there. So the first of the Granite 4Hs is a Granite 4H Micro that accompanies the Granite 4 Micro that I just talked about. So that is also a 3 billion parameter dense model, but now we have hybrid state space. Then the last two models in the family, Granite 4H Tiny and Granite 4H Small, are both hybrid state space models like the Micro, but now they are also mixture of experts, right? So these are sparse models. They have a total parameter count of 7 billion for the tiny model and 32 billion parameters for the small model. They have activated parameter counts that are lower than that. So it's a 1 billion. So on tiny, you've got 1 billion active parameters. On small, you've got 9 billion active parameters. What that means, right, for those of you who a sparse or mixture of experts designation is a new concept, that means that they have a knowledge and accuracy profile closer to their total parameter count, but they have a throughput performance profile that is closer to their activated parameter count. So what they're doing is they're picking portions of the model dynamically for each request and really at a token level to answer and kind of retain only the most important pieces of the model in answering a given request. So really, really interesting blend of technologies in that Granite 4 family.